We're going to look in this section at going from the graph to the vertex form of the equation. So we're going to do a little bit of review first. What is the vertex in each of these equations? So if you remember back to first semester, we shifted functions up, down, left, and right, and you've seen something in this form before. So if you look at number 1, we have x minus 3 squared minus 1. Do you remember how this shifts the function? Well, hopefully you remember that the minus 3 inside the parentheses shifts the function right 3, and the minus 1 on the outside of the parentheses shifts the function down 1. So let's take a look at this, see if I grab this here. Okay, so this is minus 3 would be right 3, and the minus 1 would be down 1. So the vertex, if it's right 3, down 1 would be 3, negative 1. If you remember, all quadratics, the parent function starts at 0, 0. So this one would be shifted 3 to the right, 1 down, and you could sketch the function. It would look something like this. And we would know that it's facing upwards because there is no number in front of the parentheses right here. If there was a negative, it would be downwards. Let's do the next one. You have a minus 2 inside the parentheses. So that would be right 2. And since there's nothing on the outside of the parentheses, that would be up or down 0. So the vertex would be 2, 0. The next one, x squared minus 2, the 2 on the outside would mean down 2. But there's nothing inside the parentheses, so that wouldn't mean left or right any, so the vertex would be 0, 2. The next one, plus 5 minus 4, would be left 5, down 4. So left 5 would be negative 5, down 4 would be negative 4. 5 and 6 are slightly different. They have a number on the outside. And if you didn't know what any of these look like, you could type them in the inspires and see what they look like. But the vertex here is still left 2, up 4. Left 2, up 4. The minus 3 deals with how narrow or wide the slope is. The minus 3 would mean it would be downwards facing you like this. The minus 3 would indicate a steeper slope, so it would be skinnier than the original function. The next one, the 2 on the outside, it would be a right side up u, a regular u. And the 2 would mean it would be wider than the original, or more narrow again, more narrow than the original function, so skinnier. And the vertex here would be left 3, so minus 3, and up 1. So that part is review. How do you know if the vertex is the absolute min or absolute maximum? Well, you look at the number on the outside of the parentheses. So for example, if we have y equals some negative here, like negative 2, and you had x plus 5 squared minus 7, you're just looking at this number on the outside of the parentheses. If it's a negative, that means it's facing downwards, and you would have the maximum. If you had an equation like this, y equals, how about 1/2 x plus 5 squared minus 3. Again, all you're doing is looking at the number on the outside of the parentheses, the 1/2. Since it's positive, it would be right side up u, and you would be looking at the minimum of the parabola. So the first type of question you're going to see on your assignment is this. What is the equation for the graph below? It gives you the a value, the slope value, 1 or negative 1. So this one right here, you would look at it, all right, it's an upside down u, so that slope must be negative 1. And then we look at the vertex. So here's the vertex, and that would be left 1, so x plus 1. Don't forget your square, that makes it a parabola. And then you have up 4, so plus 4. So I think the first 4 on your assignment, you pick your a value. If it's positive, it should be a regular u, and if it's negative, it will be an upside down u. And then you look at the vertex and put it into vertex form. So just a quick summary of what we just talked about. What does the a variable do to the graph of a quadratic? So if it's positive, it means that it's a U shape, right side up. If it's a negative, it means it's an upside down U. If a is between 0 and 1, then we know that it is a wider slope or wider or fatter than the original. And if it's greater than 1, it's going to be skinnier or more narrow. I'll pop this open too. If h is positive, how does the parabola move? So again, here's the formula y equals I rewrite that, x minus h squared plus k. So h is the number inside the parentheses, and again, this is review from first semester. If it's minus h, it would be right h units, and if it's plus h, it would be left. If k is positive, how does the parabola move? So I'll write this over here. K plus k is up, minus k is down. Okay. The second type of your question on your assignment is this. You'll have a quadratic. It'll say, what is the vertex? So we just went over that. The vertex here would be left 3 minus 3, down 1 minus 1. The translation, so in words, what does that mean? Again, it's left 3, down 1. Here the a value is 1. So the vertex would be negative 3, negative 1. And to find all your other points, you could plug into the function, or you could type the equation in your graphing calculator, which I'll load. And then we can use the table in the graphing calculator to graph. So again, our vertex, okay, so I'll wait for this to load. So the vertex would be negative 3, negative 1. It's going to be a U-shaped, regular U-shape because a is a positive value. So now if we go to our graphing calculator, let's see if this will load here. You could open a new graph page and you could, so let's go here. Let's open a new graph page. Type in our function. So our function was parentheses x plus 3, the squared, and then it's minus 1. So again, we can see what the graph looks like. To get our exact values, we could look at a table, and on the Inspire, if you hit Control-T, a table is going to pop up. And let's find the vertex. The vertex was negative 3, negative 1. So here's negative 3, negative 1. Let's write 2 points below it and 2 points above it. So if we go to negative 4 and negative 5, it'll be 0 and 3. So let's write that down. Negative 4, negative 5, 0, 3. And since it's a parabola, when we go to negative 2, negative 1, it's going to be symmetric. 0 and 3 will be symmetric, but we'll double check the table here. So negative 2 is 0, negative 1 is 3. So let's sketch this function, negative 5, 3, negative 4, 0, negative 2, 0, negative 1, 3. So we can get our nice sketch of our function. So you'll have a few of these where you'll have to give me the vertex, the translation up, down, left, or right, what is the a value, and then you can use your graphing calculator to sketch the function. So that'll be the second type of problem. The third and the last type of problem is, can you convert an equation in vertex form to standard form? And that means multiply it out. Now when you multiply it out, you have to use order of operations. So the first step always has to be multiply out the x plus 2, whatever's squared. You're going to multiply that out. And again, you can FOIL or use a box. I'll use a box. So what this means is x plus 2 times x plus 2. You cannot just distribute the squared because of the plus right here. So we'll have x squared, 2x, 2x, and 4. So let's rewrite that. We have y equals, we have the negative 3, and then we have what was in our box, x squared, combine like terms, plus 4x, plus 4. And then on the outside, we still have the plus 4. So again, you have to multiply out x plus 2. You have to FOIL it or use a rectangle. You cannot distribute the square. The answer you can see would not be x squared plus 4. We do have that 4x there. All right, next step with the order of operations, you distribute. And we're going to distribute the negative 3 to the terms in the parentheses. So we have y equals negative 3, x squared, minus 12, x minus 12. And again, you have the plus 4 at the bottom. Final answer, combine like terms, and we'll get y equals negative 3x squared minus 12x minus 8. And this is the equation in standard form. So we went from vertex to standard. We'll do one more, convert this to standard form. Again, the first step has to be multiply out with the rectangular FOIL, the binomial. So we have x plus 5, x plus 5. We'll get x squared, 5x, 5x, and 25. We'll rewrite y equals 2, and then in our parentheses we'll have x squared, combine like terms, so we'll have plus 10x from this, plus 25, plus 1, and we will distribute. So we have y equals 2x squared plus 10x, plus 20x, sorry, plus 50, and then remember you still have this plus 1 on the outside. Combine like terms, and the final answer is y equals 2x squared plus 20x plus 51. And this is your function in standard form. So your assignment will be those 3 types of problems. So try those. They should be the next 2 pages in your packet.